Solution. Part A. Here is the location of the vertex. We have to read the ordered pair. V is equal to the ordered pair HK for the XY. The H, or the X coordinate, is corresponds to -1 on the, right down here, on the x-axis, and the y coordinate corresponds to +4. So there is our vertex. Let's go to part B. Part B says find the axis. The axis has the equation x equals h. That's an equation you want to remember for the axis of symmetry. So that implies that for this particular problem, x equals -1 because the h coordinate is -1. Part C, we're asked to find the range, and that's just by examining the graph. The graph y values start at -infinity, but they go all the way up and include +4. So it's everything from -infinity with an open parenthesis, of course, because we do not include infinities in the boxy brackets, all the way up to 4, which gets a boxy bracket because the number 4 actually has a solid point appearing on the graph. Part D. Now, since the vertex is the point where the graph emerges in a downward position, that makes the vertex itself a maximum point. So we don't have a minimum point. We do have a max. It occurs at the ordered pair HK, which is -1, 4. It's the ordered pair XY. And if you actually want, that would imply you could actually express the max value. The max value is the y value for the maximum point. That is equal to the k coordinate. In the vertex, it's equal to 4 if they're asking for max value. Okay, and then part E, the open intervals of increase and decrease. First, let's talk about increase. Increase occurs from x equals -infinity on the x-axis all the way up to -1. And it says to use open intervals, so we'll put a round bracket. So for all the x values on the x horizontal axis from -1 to from -infinity to -1, the little ant would be climbing upward on the graph. So it's an interval of increase. And the interval of decrease, that would occur as a little ant moves from the on the x-axis, points corresponding to open parenthesis -1 all the way out to +infinity. And we are finished.